thanks everyone for coming. I really appreciate it. This is the last afternoon of the conference, so I know you have better things to do, like grab a drink. We're here to talk about Netflix's experiences automating Spark upgrades and migrations. Lots of fun. Just calling it out, the Netflix logo has not changed. We're just missing some of the colors in the presentation over the HDMI cable. So that's just gonna look a little weird, and that's okay. Yeah, so what is our problem today? Like, what are we trying to solve? So our problem is that we have unsupported versions of Spark running in production. I imagine some of you do too. Actually, who here has an old version of Spark running in production? Okay, that's not everyone, but it's close enough. And for those of you who didn't raise your hand, you might be sleeping, and that's totally okay. Thursday afternoon, I get it. I take naps too. So why is that a problem? So the old versions of Spark, I don't remember how to fix them, right? I don't remember what all the problems are in Spark 2.1. And so when it comes time to fix these problems, it's really, really painful. And so keeping these old versions around has a real cost in terms of my time, which I value greatly, but also in terms of the business, right? Like, we spend a lot of time fixing old things that's just gonna be kind of thrown away. And so it's not ideal. And even if you don't have old versions of Spark now, eventually you will, because there's always new versions of Spark making our things old. So why do we have old versions of Spark in production? API changes, right? So if your code stops working, you're probably not gonna upgrade it. The other one is that upgrading your code isn't a lot of fun. I like to think about it as like, no one really loves filing their taxes in this country. Big shout out to the companies that perhaps lobbied Congress to make it challenging to file your taxes. We don't have that for Spark API changes, but there are applications where it's easier to upgrade, right? Because the API doesn't break as much. And this isn't one of them, right? But we can try and make it less painful, and we can try and make it like a country where someone didn't lobby to make taxes hard. And so yeah. Also, testing is hard. How many people here feel like they have really good test coverage of their data pipelines? Oh, we got, yeah, okay, we got a 1 yes, but they work on a tool to do test coverage of their data pipelines. So I feel like that you might not be a representative sample. But everyone else is like, no. Right, so realistically, we don't know if things are working, right? And that's a really scary place to be in when we're making business decisions based on them, right? So people don't want to upgrade because they don't know what's going to break. So there's some things that we can do, right? We can try and make it easier. We can work on making it so that your code changes are easier. We can use abstract syntax trees and do really fun transformations on those. If you took a compilers class in university, you might be remembering this with the dragon book on the cover. Anyone? Anyone? No? Okay, you all had much cooler university experiences than I did. That's totally fine. You can just think of it as like the computer representation of your code, and it's all marked up with kinds of nice information about what the different pieces of your code are doing. And it's in a tree structure, so we can do pattern matching on it. And this is really cool. Alternatively, you might be going like, you know what? Code is just text, and I can use regular expressions on text. And for that, I say you now have 100 problems, or perhaps an uncountable number of problems. But I did read a lot of Perl books in the 90s, so I get where you're coming from. Finally, we can try and make validation work better, and this way you'll have confidence in your changes. And we can also try and make it so that you're motivated to do it, right? One of the things that the IRS does that is lovely is it lets me file an automatic extension. And I do that pretty frequently, right? And I imagine a lot of us also do that with Spark upgrades, where we're like, well, you know what? I don't have to upgrade today. I can just, pay a little bit extra for the support contract. Or alternatively, when you work at a company like Netflix, you can just be like, I'll just get the platform team to support it for a little bit longer, right? It doesn't cost anything real. It's fine. So social problem first. This is probably not super applicable to you, but to give you an idea of sort of what we did, we worked really hard to create visibility, right? I think that's sort of key. We also had org champions, and that's because Netflix is such a large company that might not make sense for smaller teams. But very important, make visibility, make people aware of what's broken, and this way they're incentivized to fix it. And now here, it looks like this is all blurred out. I assure you that's not actually intentional. There are no secrets on these slides. Don't try and decode them. But it's just the color green is happy, and we give people the color green so they feel good about themselves. If I'd been in charge of this particular part, I would have given them stickers, but instead it turns out the color green is cheaper than a sticker, and also I don't have to figure out where everyone lives. You know. But we're gonna spend most of our time focused on the computer problems. And these are the problems that we think are both more solvable and also probably more generally applicable. Like the things that we've done here, you can apply regardless of what your company structure is like. And also we can ship it as software to you. It's very difficult to ship people as software so far. Yeah. So you might be going like, Holden, why should I listen to you? So I'm on the Spark PMC. It's kind of like tenure, except it doesn't guarantee I get paid, it just guarantees I get work. So the shitty part of tenure. I've worked on Spark for almost 15 years, I think, co-author of a bunch of books on Spark. And if you have a corporate credit card, now is an excellent time to buy several copies of High Performance Spark First Edition. It is indeed completely out of date, but I make almost enough to purchase 1 cup of coffee per book sold. And that's fantastic. And actually, it looks like my co-authors here that we're working on the 2nd edition. Do you want to raise your hands and say hi? Yeah, so we're all working on a 2nd edition of the book, and you should definitely buy that when it comes out next year. You can follow me on Twitter, and you can also see some of my open source live streams. I think they're pretty fun. I'm pretty biased. And yeah, outside of work, trans, queer, Canadian, part of the broader leather community. This is supposed to be the gay pride flag. Those black bars are just from the magic of color. It's not that I don't like the color yellow. Anyways, I think it's important that we sort of like look at the kind of people we have on our team, and if it's everyone from the same background, say everyone from UC Berkeley, we maybe try and get some people with some different backgrounds involved. Bobby, take it away.
Awesome, thanks Holden. Hey guys, my name is Bobby. I'm an engineer here on the Big Data Compute team here at Netflix, and I primarily work on Spark, Iceberg, and our Hadoop infrastructure. Outside of work, I'm really passionate about fitness, so you might catch me running some half marathons. Also recently upgraded from the ukulele and learning guitar, so if anyone has any tips and tricks afterwards, feel free to find me and I'd really appreciate it. You can also follow me on GitHub at bmork. Cool, so as Holden mentioned, a big piece of the Spark migration here at Netflix was the social problem, but we won't be focused much on that here today. We're gonna be focusing on the tech. And a big piece of that tech was the managed migration tooling that we wanted to deliver to kind of end-to-end automate as much as we can the process for end users. So what was the goal? Yeah, as I mentioned, we wanted to automate and abstract as much of the migration process as possible, and thinking about how do we actually do this? The first step is actually having a robust understanding of all the variety of Spark use cases across all the various teams, Spark dialects that we have here at Netflix. And as we'll describe later, this is pretty big scale. There's quite a lot of Spark jobs running across Netflix that are serving things like your movie recommendations, so we definitely want to be migrating these properly. Next, we built the migration control and automation plane that actually monitored the state and progress of these workflows through the migration process and automated things like actually pushing code back to the upstream and communicating with downstream Spark job owners. We also, as Holden mentioned, a big piece of value that we provide to our that we can provide to our end users is validation. And Holden will describe this in a bit more detail later, but we were effectively staging Iceberg snapshots through shadow Spark job executions alongside the production run and comparing the hashes of these snapshots to each other. I won't dive too into detail just yet, as Holden will get a bit more into that. And as Holden was kind of showing, another piece we wanted to deliver to our end users was observability into the migration process. Really give our downstream org champions and Spark job owners an understanding of how their jobs are progressing, what their performance is on the new Spark job versions, and if that's all satisfactory to their use cases, and ours as well. So I want to call out a couple important caveats prior to getting into more detail. The validation tooling we built, as I mentioned, it's operating on staged Iceberg snapshots, so we weren't it's only compatible with Iceberg tables. We weren't operating on Hive tables and other data source outputs, for example, like Kafka streams or RDBMS solutions. We're not going to be talking about that here today. Also, as I mentioned, we were performing like hash-based comparisons of these staged Iceberg snapshots, so non-deterministic output couldn't really easily be validated. We could do some clever things to hack around that, but pretty much only dealing with deterministic output here. Additionally, the managed migration tooling that we're going to be describing primarily only focuses on Spark SQL and PySpark. Scala, especially due to more complex dependencies and the requirement of recompiling these jobs, that wasn't really a focus of this managed migration tooling, so we were primarily targeting Spark SQL and PySpark, which, as we'll see later, makes up the vast majority of Spark usage here at Netflix. So The color is a bit off here, and no need to feel the need to read this. This is an example of a subset of the states that's captured by the control plane from our managed migration tooling. I don't show this to have everybody attempt to read this. I don't even think it's actually possible given the color, but this is just to kind of illustrate the work that we're abstracting away from our downstream users. Distributing this work to our actual Spark job owners would be pretty arduous, and it provides a lot of value to actually automate this process away from them. But ultimately, we can think of the migration process in general ideally as a few simple steps. One, we schedule the Spark job for migration. We validate the performance data across the Spark 2 version and the migrated Spark 3 version. And ideally, we assume great success and can deploy the updated Spark code straight to prod. That's unfortunately not what happens. This validation can fail for a variety of reasons. For example, the code update tooling that we'll build and talk about a bit further, we may not have actually captured all of the breaking API changes between Spark 2 and Spark 3. We may need to iterate on that. Additionally, we may actually need to provide more white glove support to actually modify the Spark job code in more custom ways than our code update tooling is able to handle, or actually do some white glove support for tuning Spark job configs, as we'll describe in a bit more detail later. Lastly, in some cases, we actually identified some regressions from Spark 3, from Spark 2, so that in those cases, we actually would push upstream PRs to the open source, and if we have time, we can talk a bit about those today as well. And after all of this cycle of iterating, we can then successfully deploy the updated Spark code straight to prod. So as we can see here, this diagram kind of illustrates a bit of the capabilities that we're trying to bake into this managed migration tooling. So let's take a look at these bit by bit. So first, like I mentioned, we wanted to have an accurate and up-to-date understanding of the actual Spark jobs that were being leveraged here at Netflix across all the variety of Spark dialects, all across Netflix and the variety of teams. So we wanted to make sure that we had a snapshot in those in our data warehouse for the rest of the migration tooling to operate with. Next, as I mentioned, we have our migration control and automation plane that automated a lot of the work from our downstream users, like maintaining the state of the workflow throughout the migration process, scheduling it for validation, communicating with our downstream org champions and end users, and actually automating the code updates, pushing it back up to the upstream, basically completing the migration process. A big piece, like we've mentioned, of this migration tooling was actually the validation of these Spark jobs, making sure that we're maintaining similar performance and actually the data written across both versions. As Holden will describe in a bit more detail later, we did this through basically shadow snapshot Spark jobs across both the prod version and the shadow Spark jobs. Apologies also, I'm a little nervous right now. So I'm gonna keep checking through. But yeah, so effectively, we had those validation workflows. Lastly, the last thing we wanted to focus on was the observability piece that we baked into the managed migration tooling. So as we can see here, a big piece of there's a lot of capabilities that are captured in the managed migration tooling overall. And we're not gonna be focusing on all of these here today. We're gonna be focusing on the managed migration control and automation plane in the shadow Spark and validation jobs. So effectively, within the automation plane, we're gonna be focused primarily on the code update tooling, and within the shadow Spark and validation jobs, we're gonna be primarily focused on that as well. So within the code update tooling, there's a few things that we can consider when looking into this. Effectively, we can think of this from the perspective of regular expressions. As Holden mentioned, these regular expressions can be a bit complex and not super extensible. You got this. Shit. I appreciate that. Yeah, so effectively, when we think about the code update tooling that we built, we can think about how we can actually approach this. The first thing we can think about when approaching a problem like this is, okay, do we want to build some complex regular expressions? That may not always be the best solution. These regular expressions might be complex, super verbose, not super extensible or flexible. So we wanted to look at this from an abstract syntax tree perspective, like Holden was mentioning, actually leveraging some of our compiler courses from the past. So we leveraged a lot of these open source libraries, for example, ScalaFix, libcst, and SQLFluff that effectively allowed us to build configurable plugins built on top of these open source libraries that would substitute pieces of these ASTs for new pieces of code that handled these breaking API changes from Spark 2.x to 3. We didn't handle too much of Java workflows. I'm going to keep that up there. We didn't handle too much of Java workflows as we don't have that many here at Netflix. And if you want to check the open source, feel free to look at the Spark upgrade library. And we'd very much greatly appreciate if you contribute to it or if you benefit from it as well.
Yeah, pull requests are actually welcome here. We would love your pull requests.
Awesome. So before diving into examples of like what some of these rules look like, how do we actually figure out what rules to make? So we do have some things at our disposal in the open source. For example, big shout out to the open source developers who actually are contributing to the release notes. They're really great, but it is difficult to capture every single change that's being made between each minor version. And so sometimes they're incomplete, and we're not going to actually be able to use these to capture every single breaking API change. Additionally, we do have access to the Migration Manager, an online migration guide, and we can see an example of some of the changes in Spark SQL from Spark 3.0 to 3.1. But as we can see here, this is just a subset of one minor version change. This is a long, long laundry list of all these breaking API changes. So we may not actually have enough time to build an exhaustive set of rules in these code update tools that we build. So empirically, another thing we can do is actually just try and see what breaks in production on our Shadow Spark jobs.
YOLO.
And then build, and build rules retroactively. So that's another thing we did. So to take a brief digression before looking into what some of these rules actually look like, we leverage the open source SQL Fluff plugin, which serves as a linter, parser, and modifier of a variety of SQL dialects. For example, Spark SQL. But something we found at the beginning of the migration process that while this library is really flexible and extensible and great, it only was able to parse about 50% of Netflix Spark SQL queries. So we worked alongside the open source community and moved fast and really buffed up the open source Spark SQL dialect, adding new features to the dialect, such as Iceberg DDL. So really big shout out to the open source community for moving fast alongside us. So let's take a look at what some of these rules actually look like. So I want to take a quick example here. So we can see the approx percentile function here. And underlined, I think that's supposed to be red, but it looks, I mean, that's fine. So we can see that we have this optional third argument. In this case, we see that we have a float. In Spark 2.x, this would be implicitly casted at runtime to an int value. In Spark 3, for example, we get a pretty big error and nobody's going to be happy with that. So we want to actually restore that Spark 2.x behavior. And so we can actually do this, for example, through just wrapping that scalar value in a cast as shown here. So we can capture that behavior within a rule in these plugins we built. So let's take a look at what that looks like. So here we see a lot of primitives, SQL Fluff primitives. So I won't go super in detail on what the code, or like into the nuances of this, but effectively what we're seeing here is a recursive eval function that is going to be walking the AST and checking, have we found a function, and is that function the approx percentile, or equivalently the percentile approx? We want to make sure that we encounter that third argument. If we have, we don't want to be applying that cast if it's already been applied. So we're going to check, have we already wrapped that third argument in a cast? If we do, then we don't want to be modifying the AST, infinitely adding that cast and having a really poor performing query. If we haven't, then we know we can safely explicitly wrap that third argument in a cast and return the modified AST and hopefully modify or complete the migration process and push directly to prod.
Fantastic. Thanks, Bobby. So we do something very, very similar in Scala. And it's also on a tree. I love it. And in Scala, we get types. I love types. Types are fantastic. They make my life easier. So here we can see we have to write these symbol matchers, but it allows us to like say, hey, is someone calling the JSON method on the data frame reader object? And in fact, that's what we do. And then we say, OK, cool. If someone's calling the JSON method on the data frame reader object, are they calling it with an RDD? And if they are, then we do know that we need to modify the code. And so we do this with this patch.add left and add right. One of the things that I really like about Scala Fix, as opposed to SQL Fluff and some of the other tools, is it lets us still write these tree transformations, but in our results, we can just put out strings, and it does that transformation for us. So we have to like explicitly say what things are keywords and what things are different things. The parser just does its magic for us. I'm happy, I'm lazy. Similarly, you see here, we've got like the same recursing. It's on a tree, so we recurse on our tree because we're functional programming and recursion. All kinds of fun. All kinds of fun. So OK, obviously we have more than those two rules. There's a whole bunch of them. They're all in GitHub. But how do we know if it worked, right? Hope is not a plan, although that was indeed my first plan. I was like, you know what could go wrong? And it turns out the answer to that is rather a lot. And then I was like, well, you know what? We probably have OK test coverage. No, I didn't actually say that. But I was like, I really hope we have test coverage. And the answer was no, we don't have test coverage. If you're making a new Spark pipeline, please, for the love of whatever your favorite thing is, write some heckin' tests. Just do it. I wrote a Spark testing library. There are other ones. They're all great. Just use a testing library, write some tests. It's not going to be that hard. Future you or future replacement you will thank you. Yeah, and so what we ended up doing is we ended up doing these side-by-side runs. And so what we did is we took this pattern that was popularized from Netflix, I believe, by Michelle Winters in her talk, Whoops, the Numbers Are Wrong. Love it, fantastic talk. If you haven't seen it yet, definitely check it out. And what it is this idea that like, well, we probably don't have a lot of tests, but we can like kind of think about what our data should look like, and we can check to see if it looks like it before we release it to production. And so we're like, you know what, that sounds like a good idea. In this case, we actually have a different version of our pipeline, and we can see like, hey, is this the same? Like, are we getting the same output? And that's why we switched from write-audit-publish to migrate-audit-discard. So it's a very similar idea, and we stage the data. We just never publish it. 100% of the time, we discard it. And our audit step, instead of having to like involve a lot of like knowledge and thinking, is automated. And it's just like, yeah, these things should be kind of close. I'm going to round all the floats and YOLO. Cool. OK, now given that I said YOLO, you're probably like, that doesn't sound great. YOLO and success don't go together too often. And indeed, it is expensive. And it does not work 100% of the time, right? So it actually quadruples our costs, and that's because we have to run multiple copies of the pipeline. Not just two, because we also want to run a third copy, because we want to detect non-deterministic pipelines without a user having to become involved, right? So we don't want to just run two and be like, okay, these two were different, flag it for review. We run three, and we go like, okay, cool, A1 and A2 were equal, AB was not equal, flag it for review. And then on top of that, we have to compute like what is equal. And it turns out that we have really big tables. It's really inconvenient, and finding out if the data is equal is really slow. Ugh, not cool, not cool. We did some hacks to make that faster. Unfortunately, those hacks are not public, but essentially we just looked at the partitions that changed, and there's some stuff in the GitHub you can read as to how to make that happen. And it's not perfect, right? We don't catch things that do side effects, right? Like if it's going to send you an email, not great. Hopefully you don't send emails from your Spark pipelines. Just don't do that. Yeah, okay, cool. Okay, cool. Now we're going to run a demo. Huzzah! Okay. Let's hope that this works. Now, this is the open source version. It does not have our secret special sauce. And I've got a fancy shell script called run-demo.sh. And this is also in the open source version in the GitHub. So you can go and take a look at it yourself if the demo doesn't work today. Not to jinx it. OK, so what this demo does is I've got this demo project, and it makes a copy of it. Demo project's in Spark 2, and we're going to run it in Spark 3. And we start off by just like building things, making sure that the project is in a reasonable state to start with. Cool, test pass. And then this is what we would do. For the Scala users, you do have to like add the rules to your build manually. So a user would have to do this. I've scripted it here, though, so we're just going to go ahead and press enter. Ooh. And now we're going to apply Scala fix. Yay. People do not seem excited. This is unfortunate. OK. How do I make lines of text seem more interesting? Yes, good question, good question. Well, these compiler warnings are exciting. Ooh, look, OK. So here we can see that I left debug messages in. And so that's how you know it's quality code, is that it prints debug messages to standard out, because I forgot to turn that off. And in fact, that's also how you know it's a live demo rather than a pre-recorded one. And so this actually runs the rules in two sets. The first set that we did, where I just printed these random messages out, this is the like automatic rules. And here, these are the messages that I actually wanted printed out. And these are rules that are saying like, hey, this is a warning. We're not going to handle it for you automatically, or we are going to handle this for you automatically, but we might get it wrong. So like, please take action. And just like a real developer, I'm going to ignore the warnings and press enter. And then it says like, hey, you should really look at the difference. And once again, just like a real developer, nah, screw that. Okay, and then it says like, yeah, we're gonna actually run in Spark 3. Boop, huzzah! Okay, we're gonna run in Spark 3. Now, while it's running the Spark 3 pipeline, we're gonna really quickly look at the different code. SRC, man, Scala. Ooh, word count? Yes, everyone loves word count. You cannot escape it. And then we're gonna load the Spark 2 version of this. Okay, Emacs crashed? What? Oh no, don't worry, Emacs. You can watch all these files. There we go, okay. Here we see one of the differences. It did a few different things, but here we can see it changed the word value to key or key to value. I don't remember which way it did, but it changed some code. Magic! Huzzah! Yay! Thank you. Thank you for starting the clapping off. I really appreciate that. That means a lot. And yes, we could do this with a regular expression, but it turns out that people like use the word key and value in multiple places in their code, and we don't want to rewrite all of them. So the really safe way to do this is with these abstract syntax trees. Now we're going to go back to the demo, and we're going to see that it's running still. It's supposed to finish now, but it's a ThinkPad. What am I going to do? Okay, we're going to write out the Spark 2 and 3 version. We can see that it's called domagic.py. That's how you know that there were 0 program managers involved in the early phase of this project. And we run it. Huzzah, we're comparing the results, I think. No, maybe, I don't remember. Oh God, Spark is so verbose. Huzzah, success. Look, it says okay, okay? That is great. We have success, everything is fine. Now, we could go and run a second version of this that would fail by running with data that's changing underneath us. But I'm not gonna do that today because like, yeah, let's stick on the happy note, right? We could use the happy notes today, I think. Cool, so that's great. And Bobby is gonna talk about what some of our production results were.
Awesome, thanks Holden. Amazing demo, very happy it didn't crash.
I'm pretty stoked myself.
Awesome. So like I mentioned earlier, I wanted to give you folks a brief look into the scale of the Spark jobs running here at Netflix. So basically, across all the variety of Spark dialects and various teams, we're looking at about 30,000 Spark jobs run. So the scale here was pretty massive. And the vast majority of these running on Spark 3.3 became on 3.3 through the actual migration process. And as we can see on the right side, Spark SQL does make up a vast majority of the Spark usage here at Netflix. So that kind of motivated why we built our managed migration tooling targeting these workflows. Now, taking a look at the actual high-level performance indicators without getting super into the low-level details of like vCore seconds, garbage collection, peak memory usage, we do see a lot of improvements across the board for the variety of Spark SQL dialects used. Now we can think about some features in Spark 3 that contributed to this, among adaptive query execution, a better catalyst optimizer, and new language features in Scala 2.12 that contributed to this. Now, while I would say this migration was a pretty great success overall, there were some limitations in our managed migration tooling. The first one we can think about is actually in our code update tooling. We weren't able to actually natively infer types in these code update toolings. What I mean by that is, imagine, for example, we have a breaking API change like we saw earlier that requires us to cast from one type to another. In the rule we saw earlier, we saw a scalar value applied or directly within the code. If we don't have a scalar value, and for example, we have a column name or field name, we aren't able, without actually directly reaching out, for example, to the internal metadata catalog, able to infer what type that is. And we didn't want to bake in a lot of like internal logic into this open source tooling. We wanted to make it accessible to everyone.
Although now, with Unity Catalog being open source and implementing the Iceberg REST spec, if someone wants to add this support, it would be really cool if we just queried something implementing the Iceberg REST spec and asked it like, hey, what are my types here? But that's vNext.
Right, so if anyone wants to work on that with us and implement that, that would be much appreciated. I think that we'd all benefit from it. Yeah, next, taking a look into our actual validation tooling, there were some gaps in this as well. One of those gaps is while we did kick off these Shadow Spark jobs run alongside the production job very close to each other, we weren't actually freezing the Iceberg snapshots that we read from. So in some cases, for example, tables that were very frequently written to, we did see data difference in the downstream in the actual output, and that wasn't actually due to any breaking API changes or issues in the Spark job itself. So in future migrations, we definitely want to be thinking about that. Additionally, as we mentioned, we were performing hash-based comparisons of the actual staged iceberg snapshots, and we did this through Python UDFs. And as you can imagine, these are pretty slow, and in future migrations, we want to be thinking about how we can stay closer to the open source and actually rely on faster UDFs and better comparisons. But for the purposes of our migration, we did rely on these. And we'll talk. I'll take a brief digression in a couple slides about an incidental iceberg bug fix that we actually found from these slow Python UDFs. Lastly, the support model in the case of validation failure, as I mentioned, was pretty white glove. We did provide a lot of manual support, for example, Spark config tuning and actually making custom changes to the Spark job code, for example, persisting, caching, and repartitioning data at various points in the job. And as we think about future migrations, we can think about how can we automate some of this white glove support, for example, that Spark job tuning. And if we have time, we can talk a bit about how we can do that as well. So yeah, as I mentioned, this is an example of those slow Python UDFs. We leveraged the open source deep hash library. Big shout out to the developers there. As we can imagine, yeah, and as we see here, we're doing like row and column-based hashes on these Spark data frames. And as you can imagine, it's pretty slow. So slow, in fact, that what we found was on Spark executors that were creating hashes of these snapshots with more than 1 billion rows, we saw a lot of these SSL disconnect errors in our executor logs, and then the job would subsequently fail. After some investigation, what we found was effectively when reaching in between S3 reads, these hashes would take sufficiently long such that S3 would actually hang up the connection with our Spark executors, and then the job would subsequently fail. So the fix is actually pretty simple, but this did ultimately help progress the migration pretty greatly and also help migrating other slow UDFs in the rest of the Spark jobs that we were migrating. So ultimately, yeah, we just implemented a series of retries in the actual S3 input stream in core Iceberg, and great success. Holden, do you want to take it away?
Totally. So this is great. We did a lot of wonderful things, but obviously we didn't catch everything. And one of the things that is sort of challenging is dependencies. The open source dependencies were largely migrated by the time we got there, but internally there's sort of like a dependency graph of different libraries that people have created, and getting that ordering for the upgrading is really challenging. This is true in open source. It's just generally, it happens before I get around to upgrading my internal stuff. Or sorry, not I, we. Programming language version changes. I know this is something that in Spark Connect we may reduce the pain for some users, but we have a lot of old Scala code, and that's just really painful because we have to update the old Scala code to a version that's supported by the new version of Spark. But in conclusion, great success. No more Spark 2x at Netflix. If you do work at Netflix, you know that that is a lie. There are 3 pipelines, right? Is it 3 or 4?
I mean, if we're counting Caspactor, it's a lot more, but.
Caspactor counts as 1.
Okay, fair enough. Yeah.
So I think 3.
3, yes.
3, yeah, okay. 3 pipelines on Spark 2, and that's great. That's very exciting. And you get to deal with the rest because I'm going on leave. But I'm fully confident that Bobby has got this in hand. I'm going to come back in 3 months and everything's going to be great. If you want to upgrade Spark and are lazy like us, please use our tool. If you're not lazy and you want to make my life easier, please contribute to our tool. I'd love that. Also, shout out to our employer. They are hiring. And in fact, if you throughout this talk been like, you know what, those folks seem really awesome, and I'm a manager. I wish I had those people on my team. You too could come to Netflix and be our manager. Seriously, we're hiring for a manager. And if you know Spark and you're awesome and this seems like fun, yeah, come join us. Great news, we're not going to break every API just because we've got magical tools. That's always a worry when you make tools too powerful. The good news is we're lazy, so that's not a worry. The amazing news is that my dog is cute AF. It would be, actually, I think, honestly, the colors here look even better. Whatever colors are getting dropped is just making this look like an Instagram filter of amazingness. I love it. He's great. It's the reason I still have a job. Well, that in healthcare, but whatever. Okay, so this is the thank you slide. We got 5 minutes, so I want to take a quick poll. Who wants to do bonus content for the next 5 minutes?
Alternatively, Q&A.
Okay, yeah, and if you want to do Q&A, raise your hand. Okay, you come find me afterwards. I got a lot of pictures on my phone, and I am more than happy to share. But yeah, let's go ahead and do some bonus content. Bobby, you got
Yeah,
this.
so brief look into some bonus content. Yeah, as we mentioned kind of earlier in the limitations of the managed migration tooling, it kind of motivates a look into the future of the Spark migrations. Starting with Spark 3.5, there's actually, the open source has some native data frame comparisons. Now, these probably aren't robust enough for our purposes, so we'd probably have to do actually push a lot to the upstream to make sure that we're actually able to leverage that. But staying closer to the open source instead of leveraging these slow Python UDFs is definitely something we want to look forward to in the future. Additionally, like I mentioned, one of the primary limitations was that white glove support model definitely was quite a bottleneck. So leveraging generative AI and LLM tooling to automate Spark job config tuning is something we're investing in and thinking about, not only for future Spark migrations, but generally for our downstream data scientists overall. Additionally, rather than doing this pretty heavy lift from going from Spark versions like 2.1 all the way to 3.3, we want to do smaller micro migrations to stay closer to the open source rather than having to do massive heavy lifts like this every few years. So that's another thing that we'd recommend to everyone here and certainly are going to be taking to heart ourselves.
I don't know if our partners agree with that, though. We're going to find out. We're going to find out.
Yeah, so diving very briefly into like leveraging generative AI to automate Spark job config tuning, we're starting to take a look at this internally. So I'm sure a lot of you are familiar with like Spark history files. We've forked an open source Spark Lens repo. I'm not sure if folks have heard of it. Is it by Qobel?
Yeah, Spark Lens came out of Qobel. It
right.
hasn't been updated for a while, and so we made a fork of it and updated it to Spark 3, and also started adding some additional analyzer rules to it. Right. And if you're interested in adding analyzer rules, please come and join us.
So effectively, for those who aren't familiar, like Spark Lens will take these Spark history files that actually power the Spark UI, if you're looking at it kind of like retroactively, and Spark Lens will give, I'd say, more advanced Spark users good insight into the things like data skew, memory utilization, and we can effectively feed this analysis into like custom LLM tooling to provide Spark conf recommendations. Now, as I'm sure a lot of you are already aware, LLM is really great at hallucinating, so we do need to be careful about how we leverage this and build carefully. We could end up having some pretty bad conf recommendations, so really being careful about how we get this done is going to be critical. But yeah, having that flywheel of being able to leverage the LLM tooling and modify the Spark confs is going to really automate, reduce some of those bottlenecks we saw in this Spark migration and definitely provide a better user experience. Also some tips and tricks. How many of us have seen this? And how many of us have looked like that? I'm sure probably all of us.
I didn't have the beard, mind you, but yeah.
Yeah, that's actually very interesting. Yeah, wow. Yeah, so over the course of this migration, aside from when we were actually fixing some of the regressions we found, we can't always just be powering through and pushing a ton of commits up to upstream Spark. Sometimes we do have to provide short-term stopgaps through modifying the Spark conf directly. And some of those things, for folks who might find this useful, that we've general strategies we apply is changing the broadcast join threshold, especially in the case we see like high driver memory. You can reduce that, or in the case in some cases even disable it, and that might get the job over the hump. Additionally, while we do see a lot of great new features in Spark 3.3 like adaptive core execution, AQE, sometimes in some special use cases, without going too into the details, it doesn't actually work too well, and so you might want to disable that. Also, just doing a bunch of memory tuning, experimenting with that. Hopefully the LLM tooling, if we get that built out, that's going to automate a lot of that process, but you might find it useful to do a lot of driver memory and executor memory tuning. Also, adjusting the parallelism and number of partitions is going to be pretty critical, especially as the query plan might change across from Spark 2 and Spark 3. You might need a different number of shuffle partitions or general level of parallelism. I see we only have a minute left, so I don't think we'll have too much time for the rest.
Next slide, we got it.
Okay, so sometimes when we actually have to change some of these configs, it's indicative of an actual regression in Spark. We don't always just want to be kind of duct taping these solutions onto our Spark jobs. We also want to actually be analyzing, why do we have to increase driver memory? Why do we have to go from 4 gigabytes to 64 gigabytes of driver memory? That's usually not a good sign. So in some cases, we did actually catch some regressions. And some of these we patched internally. Some of them were fixed in the upstream and further Spark versions. I'll go into a bit of them here. It's probably worth a longer form talk about how we actually go about diagnosing and fixing these. So perhaps that would be in the future. But some of these, for example, I'll go, okay, we're out of time.
We're at time. Thank
Yeah.
you so much. Everyone, you've been awesome. Thank you for coming on a Thursday afternoon. I know you've got a lot of different options, so we really appreciate you spending the time with us. We can be out in the hallway, so we're not blocking the next presenter setting up. And if anyone wants to come and ask us questions one-on-one, see pictures of my dog, that sort of stuff, we'll be out in the hallway for a little while. Thank you all. I hope you have a wonderful rest of your summit.